Hello, everybody. Myself, Yogesh Prabhu, and I will be teaching Operation Research to you all. This is the lecture one of the series. I have planned this entire crash course primarily looking at the exam. We have exam coming in like a week's time. So now we will start with the first lecture. Before we get into the lecture and address of today, the today's topic is going to be transportation and assignment. But before that, I just want to give you a brief introduction. Look, I really understand that we are absolutely low on time. Okay, hardly a week's time. Okay, so here I basically want to keep everything like short and sweet and to the point. So, and the introduction start exactly that way. Now, the first thing first, let me just explain to you what OR is all about, and I can talk about OR for hours, if not days, for sure. But just give you one word for OR, and the one word for OR is optimization. So when we say OR, okay, if anyone asks you what is OR, the uh, the deal here is we want to basically optimize. Okay. Now the meaning of the word optimum itself is to find the best values. So here, primarily what we're going to do is we're going to find out the best values, best value of a best profit and the best cost of doing a particular business. So that's how it is going to be. Now the paper pattern, as you know, it's going to be total 75 marks. Okay, and we have 5 questions altogether. So 15 marks per question is how the syllabus is going to be. Let me just quickly check if everything is going fine so far. Is everybody can hear what I'm saying? Sandeep, is it a thumbs up? It's all good. Okay, so let's start again. Okay, so now total 75 marks, and you have five questions into 15 marks per question is how you're going to get the 75 marks, right? And in today's lecture, we will address like the one of the question, and the topic of that the chapter for these questions is going to be transportation and assignment. All right. So it is very ambitious, okay, to cover 2 chapters of a subject like OR in like 2 hours. So I'm just going to keep it to the point, okay? And now let's get started. Okay. On the WhatsApp group, I have given you one handout, okay? And there is one question. Now this question I have straight taken from the latest exam paper. So this was last year's paper's question. And let me transportation work. So we have officially started with the chapter of transportation. And this is the first. This is one of the question from now. Let's just cut introduction short. Just remember that when it is OR, it is all about optimizing, the best answer, the best value of profit, and the best value of cost. The minimum cost and the maximum profit is what we're gonna do here. And let's start right, with the question that I have in hand at hand. So we have the first question of transportation. I will tell you how it works. Basically, transportation question wants you to find out the right transportation schedule. Okay, so here, if you can see, let me briefly explain what the question is. The entire, the proper full typed question is sent to you on the group. You can check that out later. But as of now, you can see here there are 3 factories like F1, F2, F3, and there are 4 warehouses, W1 to W4, and all this data is given to you. Okay, so you can see the factory 1, 2, 3 has got the supply capacity of 800, 600,000, and warehouse demand is also given to you in the problem. And I also have the question paper. So let me write down. There are a few more things given. Now, this number here is right. Give me a minute to write this down. 100, 500, 500, 200. So, well, so these are the numbers. So now, well, I just wanted to explain to you what these numbers are all about. It is given to you that from factory 1 to warehouse 1, the unit cost, the cost of transportation is 12 rupees per unit, and we are transporting 300 units. Okay, so there are 300 goods going from factory 1 to warehouse 1, like that. From factory 1 to warehouse 2, there are 500 units transported. From factory 2 to warehouse 1, there are 100 units transported. So all those details are given to you in this problem. And the question says, test the solution for optimality using modified distribution method. So I'm going to teach you how it is done. So this pretty much is a data sheet that we have. Now from this data sheet, we will figure out whether it is a optimum solution or not. So the question here is we have to find out if the solution that we figured out here is good enough or not, and to check that there are some steps that we will follow. Now let me start solving this. Let me begin solution over here. Now in the solution, the first thing I will do is I will draw something called as a cost and delta table. Okay, so see how this works. For this particular question, I'll write down a cost and delta table. Now, well, look, this is a table over here, and there are 3 rows and 4 columns. See how the table is drawn. Well, the cost and delta table is also called as UV table. Okay, now this table is like this, that we will write down the cost of allocation. So now here the cost of allocations are 12, 6, 6, 15, 17 and 7. So these are the costs of allocation from the given question that I wrote down all the costs. Now once I write down the cost, this table is also called as a UV table. So you write down U here and V here. Now let me teach you the procedure. Okay, so let me give you a quick recap. Look, we have this data given. Okay, we know that factory 1 is transporting 300 units to warehouse 1, and that is costing me 12 rupees per unit. So now if it is 12 rupees per unit, 12 into 300 is the amount that I am paying for doing the transportation. Okay, that's the cost of transportation. Now what I am trying to do with the cost and delta table is I am trying to check if whatever I figured out here is really the best, because we want to find out if the answer that we got is best or not. And to do that, we do something called as a UV table. Now I'm going to teach you one procedure, and the procedure is called as a UV table, and see how it is done to find out if it is optimum or not. Okay, you will put 1 0 to begin with. So let me say I'll put a 0 here. Okay, this is my starting point, and you can put down 0 wherever you want. Now look at this procedure carefully. Once you put 0 here, you have to make sure that the number, now this number is 15. Now I'll tell you why it is 15. Because these two, the two outside blue numbers should add up to 15. Okay, so that is how we choose that U and V. Now similar way, if this is 0 and this is 17, you have to guess a number over here which is going to add up with this number and give you 17. Okay, so that's going to be 17. Okay, now pay attention to this. If I have 7 here, and say if this is 17, okay, so I have to guess what is the number over here. And the number here is going to be minus 10. I hope you got the point, that from all the cost values that I have in the table, okay, I have to make sure that if this is 7, okay, these two numbers should add up to 7. Okay, so now that way we'll find out more values. Supposing if I have 6 over here, and say this is 15, I have to figure out a number here which will give me, which will add up to say 15 and give me 6. What will be that number? I have to subtract, say supposing if I subtract 10, I'll get 5. How about I subtract 9? So now just see whether 15 minus 9 is 6 or not. Is it 6? Alright, so that way we find out this value. Now let's go and find out the next value. Look, if you try and find out this answer here, okay, you just can't do that because there is no number right in front of it, but you can try something else. Okay, you can find out this value first. If this is minus 9 and this is 12, how much is this going to be? 21. Huh? What is this value going to be? 21. So
20.
20 minus 9 would be 11. Right. So I want to make sure that these two add up to this number here, right? And then I want to find out this value. Okay. Now 21, what number I'll add up so that I get 6? What number is that? 21 minus
14.
14. 21 minus, yeah, just do the calculation, man. 14 is it? Minus 14 is it?
Yeah. That's a UV, that's 20, not 21.
That's 20, is it?
Yeah.
I made a mistake there. 20, and then this is? No, there's a mistake here. Okay, let me get the calculations right. So once we have 0 here, 0, 15, 0, 17, and minus 10. If it is 17, this is minus 10. Okay, and that's fine, correct. And if this is 20, then this is minus, this is, I want 6, that's correct. 20 minus 9, there is a mistake here, 1 minute. So 15, 17. Okay, so when you make a mistake like that, you do the calculations again. Okay, okay, just hold this.
स्क्रीन थोड़ा लैग है वो बंद
Lagging आ रहा है क्या?
प्रॉपर आ जाएगा
अच्छा, that I have to shut down. Just 1 minute. लाइव में लाइक आ रहा है क्या?
मेरे को मैसेज आया दो तीन प्रॉपर्टी कि उस पे बंद कर दिया तो स्ट्रीम प्रॉपर
नहीं, मैंने ये कम कर दिया. तेरा सिर्फ
मैं तो
डेटा.
निकाल गया मैं अपने इंटरनेट पे
हाँ, अच्छा, निकाल दिया क्या? बहुत कम हुआ है. Okay, on is it?
Yeah.
Is it better? Just check if there is no lag. Okay. Okay, so getting back to the transportation problem, guys. Listen. Okay. We have now a quick recap. Okay. We have a table given which says that how should you transport from factory 1, take 300 units to warehouse 1, and so like, all that is given to you. So you have a solution. Now, once you have a solution, next the question is asking you, check if the solution is optimum or not. And when that is the question, to check the optimality, we do it by solving it by cost and delta table, or it is also called as a UV table. Okay, how do we do that? I'm just like doing a quick recap. Write down the cost. Look, these numbers in the corner, those are the cost numbers. Okay, so write down these numbers in the corner over here of allocations only. So now why am I not taking 9? Because 9 has got no allocations, so I'll not take 9. Okay, I'm taking 6 because it has got the allocation. I hope you got the point. Okay, so now once I have a cost values ready, now look, this table clearly says cost and delta table. So far we've got all the cost values, correct? Now next what you want to find out is delta values. But to find delta values, we need U and V. Now let me teach you how it is done. Okay, to find UV values, okay, you have to start with a 0 anywhere you want. So now what I'm going to do is I'm going to start with this 0. This is just a starting 0, okay? Now when I take this as a starting 0, I have to find out the other values. Okay, you will assume 0 only once, huh? And once you assume this 1 0, you find out the next value such that this value outside the V value and U should add up to 15 to this number. You have to make sure that U and V, the value should add up to 15. That's how it is done. Now just keep doing that. Make sure that you have a value over here which will add up to the 0 and gives you 17, which is 17 of course. So the outer two values will add up to the vicinity. I hope you got the point. Now you just have to guess more. So what is going to be the value over here? What should I write? If I write 10, now 10 and 17 will add up to 27. You don't want that. You want this and this to add up to 7, right? So how about you write down minus 10 here? I hope you really got this now. Okay, so that way we just have to find out all the U and V values. Now, well, once I have 15 here, I can find out this number. Now I have to guess a number which will add up to 15 and give me 6. 15 minus 10 would give me 5. So 15 minus, what is that? 15 minus 10 will give me 5. 15 minus 9 will give me 6. That was correct. Minus 9 is correct, right? Okay, so once I get that minus 9, now I want to figure out for 12. So if I have 12 over here, what number I'll get here? 20 minus 9 would be 11. So it is 21. That was all good. Okay. Right? And you maybe can respond in the chat. Anyway, so now we have 6 here and that is 21 over there. So 21 minus 15 would be 6. Okay, 21 minus 15 will give me 6. That's correct. All good. So Anyway, so I found out all the UV values. Okay, and once I find UV values, the next thing that we'll do is find deltas. So now I'll teach you how to find delta. So now this table will tell us whether the solution is optimal or not. Now to find delta, you can use a formula, and the formula here for delta is U plus V minus cos. So you'll use this formula and find delta. Okay, just have to remember the formula. The formula is U plus V minus cos. Okay, now how do we do that? For delta, you just put it in the circle so it looks different, and I'm using even the red color. Is the red color visible properly in the here? Okay, so now, let's find delta. The formula for delta is U plus V minus cos. Let's do that. For this delta, now I'm going to find out this delta here. So let's do U plus V. U plus V is going to be 0 plus 21, which is, this is a U value and that's a V value. So just add these two, 21, and 21 minus 20. The corresponding value of cost over here, you will get cost from here. 21 minus 20 is going to be 1. Okay. And then let's find delta here. Make sure you put delta in circles so that it looks different than your cost numbers. Okay, make sure you do that. Okay, for this delta, okay, over here, now pay attention. We have U is minus 10 and you have V as 21. So add the two. So if you add the two, 21 minus 10 will give me 11. And 11 minus the cost of this cell, this cell over here is 25. So that's 11 minus 25. 11 minus 25 कितना होता है? Minus 14, right? So that way you find all the delta values over here. So now this delta, okay, how will that work? U is minus 15 and V is 15. The sum is 0 and 0 minus 11 is minus 11. And then find delta here. So 15 and minus 10 will give you, I should have done these calculations beforehand, but anyways, 15 minus 10 would be 5. Plus 5, right? And then 5 minus 12 would be minus 7. Alright. And 17 minus 9. Yo, what is it? 17 minus 9 would be 8. Minus 10 would be 7. 8, right? 8 minus 9. Minus 1? Okay. So, and then the next value here is 15 minus 17 minus 15 is 2. 2 minus 15 is minus 13. Okay. So we have got all delta values finally. Okay, so once you get that, I'm usually not used to solving this so much. Usually students solve it. You can always reply in the chat with these answers. I'm horrible with this number. I need calculator all the time. But anyways, now we found out all the delta values, right? So after you find out delta values, okay, all these values, we hope these values are negative. But right now we have got one positive delta value. Now we write on the conclusion to this one. And the conclusion here is, since all delta values are not less than or equal to 0, we should have got all of them negative, but that is not the case. We got one positive number here. Therefore,
सर पूरा स्ट्रीम पे लोड आ गया है
क्यों?
किसी का खुल नहीं रहा.
अच्छा, it's not opening, huh?
Carry on.
हाँ, तो anyway, so therefore it is not. Okay, so basically we were expecting all the values of delta to be negative, and then there is one positive value, so that we call it not optimal. Is it going fine? Is the connectivity there?
It's lagging, but
It's lagging, huh? Okay.
Audio is clear.
Audio is clear, right? Okay, guys, anyways, let me just to tell you that we are trying this live online thing for the very first time. So let's just hope that everything works out fine. Otherwise, we always have an option that we can record the video and, you know, circulate it, and then we can discuss things on the group. And then there is Sandeep helping me out over here. Anyway, so that's about it. So just see if it is going fine. We will continue. We'll just complete this problem first. Anyway, so we've got all delta values, and then except one is positive, everything else is negative. So we will conclude that this is not optimum. Okay, when it is not optimum, okay, the next thing I'll do is I'll draw an allocation table. Now, allocation table is the table of allocations, right? So we will just write down all the allocations from the main table, and the allocations are 300, 500, 100, 500, 200, and 800. Now these are the original allocations, those are given in the problem. So I've got them over here. And now there is a whole lot of procedure that I want to teach you how to modify allocation for better. Look, this original allocation turned out to be not optimum. And in OR, we basically want the answer to be optimum, right? Now for optimum, what we'll do is we'll modify this. And to modify these values, there is a technique. And the technique is like this. What is it? Oh, not readable. Huh? Can you better the data? Excuse me. Can you can you improve the quality like 720p? Is everyone able to hear and see everything properly? Reply क्या रहा होगा?
Reply लोग का यही आ रहा है, laggy.
It's very laggy ना?
Upload करने बोल रहे हैं.
हाँ. तो let's record and upload ना.
Actually अभी 720 पे आ रहा है बहुत अच्छा.
720 पे clear है?
720 पे करना पड़ेगा तो ही आएगा.
नहीं, I think people have to watch on 720.
वही.
अच्छा. टेक्स्ट में रिप्लाई क्या आ रहा है?
यूट्यूब पे तो बंद हो गए कमेंट, अभी प्राइवेट में आ रहे हैं कि वही वो इसमें भी कुछ क्वालिटी सेट करना है.
क्वालिटी सेट तो किया है ना हम लोग ने.
हाँ. कितना रखा है?
I think too much loud. Continue, it's fine. We can understand. 16 people are watching. Yeah, this is not what we expected. Completed. If this is not really going fine, you just like let us know in the comments and maybe we can just know. Let's see how it. Allocation table. Okay, allocation table is basically all the allocations that I'm writing down. Okay, from the main table. Now, well, the allocations worked out to be not optimum, and not optimum is not best. So, if the allocations are not optimum, we have to modify and make them optimum. Now, how to make them optimum? There is a procedure to that, and the procedure goes something like this. Okay, what we do is, these are the delta values over here. Now look at only delta, the circled values. Now in the delta values, whichever one is your highest positive delta, okay, you have to put a tick mark over there. And that tick mark you please carry forward to your allocation table. Okay, now this is the place where you have positive delta. So put a tick mark here. Now as soon as you put a tick mark here, okay, now there is a technique or the procedure. The procedure is you should start a loop from here. Now, how do you draw a loop? There is only one rule to loop, that you can draw a loop and make sure the loop's corner has got some value. So, now if you see this loop, if I draw a loop like this, now this loop is valid. And the reason is all corners are occupied. So that you have to make sure that all corners of the loop are occupied and one corner will occupy. So you cannot draw a loop like this. The reason is then this corner is not occupied. And always remember you can have only one loop, or the loops are always unique. Okay, so draw a loop. Okay, once you draw a loop, put a plus sign on a tick. Okay, so that plus is in the bracket. Okay, I'm just like teaching you the procedure. After that plus, go, the next corner gets a negative. and the next corner gets positive, and the next corner gets negative again. So put alternate plus or minus signs. Okay. Once you do that, from this table, there is something called as a change that you identify, and change is the smallest number of negative corner. Now we identify something called as change, which is the smallest number of the negative corner. First of all, I've got two negative corners. Okay, these two are positive corners. And on the negative corner, I've got 300 and 500. So the smaller value of the two is 300. Okay, so please note this point that change is the smallest number of the negative corner. I got 300. Now once you identify change, after you do that, next you will draw is modified allocations. Now see how that works. So these are like three tables. Now this is the third table in the series. Now in the modified allocation, first thing first, all the values that are not on the corner of the loop will remain as it is. So this 500 remains as it is, 200 remains as it is, 800 remains as it is. If the number is not on the corner of the loop, it remains as it is. So this 500 is not on the corner, right? And of course 200 and 800, they will remain as it is, but all the corners of the loop will get modified. Now how do they get modified? We have 300, the original answer, original value, and you subtract 300. So 300 minus 300 is just gone. So now this becomes empty. And now you have 100 and the sign is positive. So you add 100 and 300. So you get 400. Now from 500 you subtract 300. You get 200 over here. And you have nothing over here at the tick. But then your change is 300 and there is a plus sign. So you add 300. I hope you realize what I did. That with the logic of loop, I have modified like these four places precisely. Now, whatever modifications we have done, the modifications are done for good. The original allocations, if you see, had 300 over here, which is now removed. Can you see that? And then instead of 100, we're giving 400. So we basically modified the given question. Okay? And once we modify the allocation, this is basically we've done fine tuning of the original question asked, original allocation given to us. Well, so we have a modified one, right? And modification is for good, as I said. Now, after you modify the allocation, the next you will do is you will again check these. Like we checked the original question with the cost and delta table. Now you will draw cost and delta table for the modified allocation. Now just pay attention, okay? Next is going to be cost and delta table, which is also called as UV table. Okay, cost and delta table is also called as UV table. I'm just going to do the same procedure once again over here. Now, but now the cost and delta table is for these allocations. So now let me draw the table here. Is it going out of the frame? Is it in the frame? Is this in the frame?
Yeah.
It is in the frame, right?
Yeah.
Okay. Alright, so we have UV. Okay, so let's do that procedure again. Now, let me go very slow and let's just like solve all this, okay? Well, we have the modified allocations and the cost and delta table will be the cost of allocation. So, cost of allocation of 500. Now, for the cost, you have to look at the main table. So, this is 500. This cell has got cost 6. So, the original cost you will get from that table, okay? Now, we have 300. 300 is worth, the cost per unit is 20. This is 15 and 17 and 7 and this is 6. So basically I've got cost of all these allocations from the main table ready. Now it's time to find U, V values. The blue values like I've done before, the same procedure, but let me explain that one more time. Okay, now concentrate on this one. Well, we start with a 0 and you can put 0 anywhere you want. It's completely your choice, okay? So I can just put 0 anywhere I want, but then it's smart to put 0 here, because if I put 0 here, I'm now getting it. Anyway, if you put 0 here, now you have to guess this value here such that the outer two values will add up to this. Now like that, if this is 0, what is the value here? 15 and 17, there you go. And then I've got other values to find. Now how will I find this value here? If it is 7 here and the V value is 17, that's a V value, that is 17. 17 and 7, I need something over here. Let's say 10. Now what happens? 10 and 17 added to 27. We don't want that, we want 7. So now this is minus 10. Is that correct? Keep guessing the values. Now it's just a guesswork. So if you have 6 here and this is 20, okay, that's going to be minus 14. That will give me 6. And then this is 15 and this is 6. How much is that going to be? 15 minus 10 would be 5. Minus 9 would be 6. All good. Now, once you find all U's and V's, you find out the delta values. And always make sure you put deltas in your circle. They should look different than the cost numbers. Anyway, so for delta value, what is the formula for delta? The formula for delta is written here, that is U plus V minus cost. So if we do U plus V minus cost, this is minus 10 plus 20, that is 10, minus cost, the cost is here, that is 25. That's minus 15, right? Let's do that here. Now 15 minus 10 is 5. 50, U plus V, right? 15 minus 10 is 5. And 5 minus 12 is minus 7. Let's find deltas and all the vacant places here. Now this delta is going to be 20 minus 9, which is 20 minus 9 is 11. 11 minus 12 is minus 1. And then next is 15 minus 14 is 1. And U plus V we're doing. So for this delta, U plus V is going to be 15 minus 14. Add the two, you get 1. And 1 minus 11 is going to be minus 10. Okay. And then here, Sandeep, do you have answers? 17 minus 9.
Minus 1.
17 minus 9 would be 17 minus 10 would be 7. 8, right? Okay, 8 and minus 9. That's going to be minus 1. Alright, and then this is 17 minus 14 is 3. Yeah, that's easy. 3 minus 15 is minus 12. Alright. Now I just want you to compare the two cost data table. One, this has had one positive value, and if you see here, these all deltas are negative. Right? So if you have all deltas negative, you write down since all delta values are less than or equal to 0. Now this, therefore, this is it out of the frame?
No.
This is optimum solution. So finally, we've got the optimum solution, right? And this is the final answer. So we have verified that this answer is optimum. Now the meaning of word optimum, I just mentioned in the intro. I don't know if you heard that. That OR or operation result is all about finding optimum. Okay, and optimum simply means the best. The best. So please understand that this is cost data table verified that the answer that you got after modification is the best answer. Now once you get that, well, this is their final answer. Write it down, and that's about it. So that's the question number 1. Now how do we write the final answer? Just make sure you write it in a proper way. That these are factories. Okay, the factories are well, these are F1, F2, F3, and these are warehouses, warehouse 1, warehouse 2, warehouse 3, and warehouse 4, W1, W2, W4. And this is your final answer. This is the clear winner. And we will write down this final answer. This is factories. Okay. Then you write down warehouses, and then the total units and cost per unit. And then I'll write down the total cost. Okay, is it visible? The green or no? It's not, right? Okay, I'll use black then. Okay, so now if you can see, the factory 1 is transporting 500 and 300 to warehouse 2, warehouse 3. It's written like this. Factory 1 will transport to warehouse 2 and warehouse 3 500 and 300 units. And you can actually check the cost from here itself. You don't have to go back to that table. You can see 6 and 20. 6 and 20. Now, is that 3,000? And then 6,000, that's the total cost. 20 rupees per unit and total 300 units, that gives me 6,000. Like that you write down for all the factories and warehouses. So factory 2 is going to transport to warehouse 1 and warehouse 3, and then this is going to be 400 and 200. I'm getting numbers from here, and I can get costs from here. 6 and 15. Just multiply, get these numbers anyways. F3, factory 3, W3 and W4, and the numbers are 200, 800, and the costs are 17 and 7, and you find the grand total. Do we have the answer, the final answer? How much is that? Is that correct? Is it working out the same way? Now, if you add these numbers, just see the numbers if they're matching. And this is the total minimum cost of transportation. Are they matching? It's all good. Give me the final answer then. It looks like after you add these give me these numbers, na? 2400 and 3000,
3400,
3400. You see, I'm really used to student solving for me. Anyways, then 5600 and too much reliance on calculator there.
2,34,000.
Is 2 lakh? No. 234. To 23,000. 234. Is that 23,400?
Yes.
Alright, no problem. So, hey, finally we solved it. So this is the what, transportation, the first problem. Okay, so quick recap, shall we? Shall we do quick recap? Just give me 1 minute. Okay, so shall we do a quick recap of the question? Okay, let's see. The name of the chapter is transportation. Okay, and this question is from the exam paper itself. Well, that question is sent to the group, so you can always look at that handout for the question itself. Well, the question is like this: that we have 3 factories and 4 warehouses. The supply of the factory is given. Demand of the warehouse is all that is given. They have decided the factory 1 is going to transport 300 units to warehouse 1. Those are the numbers in the circle. And the numbers in the corner are all the cost given to you. Alright? Now the question says test the solution for optimality using modified distribution method. Now modified distribution method has got one technique called as cost and delta table, which is also called as a UV table. And this basically verifies if the table, if the answer is optimal or not. Okay, so well, how do we do that? First, write down all the cost of allocations, and then once you write down all the cost of allocations, find out U's and V's. How do you find UV values? Just start with a 0, and the outer 2 numbers should add up to the cost value. And then find all the deltas, and expect deltas to be negative, all of them to be negative. And that did not happen, so you say since all delta values are not less than or equal to 0, 0 is also fine. It is not optimum. So first time whatever is given is not optimum, so we check. Okay, that was like the question number 1 to test, and we did the testing. Now, if the solution is not optimum, the next question says if the solution is not optimum, find optimum solution by modifying it. So now to modify 2 more tables, one is allocation table, another is modified allocation. Now for allocation table, well, these are the allocations. Now the numbers in the circle are allocation numbers. Once we write that, put a tick at the highest positive delta. Once you put a tick over here, okay, draw a loop. Now the logic for drawing loop is you just have to make sure that the corner of the loop is occupied. So you cannot take a loop like this or any other way. And always remember the loop is always going to be unique. You cannot have 2 different loops in the same questions. That's always going to be unique. And then you figure out the change. And there is a rule to change also. The change is the smallest number of the negative corner. So now we have got 2 negative corners here, and one is 500, another is 3. So the smallest number is going to be 300. And from that, wherever, see now this is a 100 value already, and then there is a plus sign. So 100 plus the change. So you add change when there is plus. You subtract the change when it is minus. So you do 500 minus 300, which is 200. That way you modify the allocations. Once you modify the allocations, again you have to check, and you check that using cost and delta table, which is exact same procedure like that one. And the difference between these two is check that using cost and delta table, which is exact same procedure like that one. And the difference between these two is over here I got one delta positive, and on the second table I've got all deltas negative. Okay, so well, once I get all delta values negative, that's exactly what I'm looking for. When all delta values are negative, it is optimum solution. And once you get the optimal solution, write down the final answer because it is said find the optimal transportation cost. Write down the answer as a factory's warehouse, the units and the cost per unit and total cost. Add them all, and then you get final answer as 23,400, and that is going to be total minimum cost of transportation. This is like question of 7.5 marks. Yeah.
RIM condition.
Rim condition के बारे में ना, we will talk all that about in theory when we discuss.
Or
We can just now, if you have any questions, you can just like put them in the comments, and then I can address. This is the question number 1 of the sheet, and then after we complete this, the next we will solve another question. Look, there is check of optimality, something that we did. Now we'll take up one more question of transportation, and we will solve that also after this. We'll just like take 5 minutes time. Let me read your comments and questions if you have any. You can post them, and then we can start with the second question in like 5 minutes time. Okay. So I'll keep this on. 47 minutes to ho gaya.
ये डालने के बाद ये भी रिकॉर्डेड रहेगा
चलो कर दी
रिकॉर्ड ये हो जाएगा
क्वेश्चन बोल देना मेरे को
हाँ
कितना प्लान्स और कितना करेगा सर Now we are starting with the second question. Let me first write down the question and then we will start discussing and I'll solve that question completely. Okay. Well, this is again transportation. Transportation. Okay. And Sandeep, please read out the question for me.
market plants 3 markets
Plants and markets, right?
yeah,
Okay.
markets.
The question is like this. We have plants like plant 1, plant 2 and plant 3. And we have markets M1, M2, M3. Let's write this down. You should extend these lines. Okay. Okay. Plant will have supply, and markets will have demand. Okay. Give me supply of plant 1, 2, 3. 2000 is it?
yeah
Read na.
2000
And the demand is?
1500
Hmm.
3000
Hmm.
1500
Hmm. And give me these numbers row. All of them. 9,
10
10,
8
8,
13
13,
11
11,
15
15,
3
3,
1
1,
0
0. Okay guys, this question is there already on the group, so you can refer to that question. I'm going to solve this question full and I'll explain everything about this question and explain the transportation with it also. Okay, so here it goes. We have 3 plants, we have 3 markets. And now, unlike the last question, we don't know the schedule. It is not given. So, what should be the transportation? Now, you have to figure that out. Okay. So, we will solve this question to figure out. Okay, what is going to be the transportation schedule in this particular list. Now, pay attention. Okay, usually a transportation question is a 2-stage problem. And in the previous problem, what we did was stage 2. Stage 2 is called as a modified distribution, which is like a fine tuning. Okay, right now we are solving and finding the initial answer itself. Okay, unlike the last problem which was given. Anyway, this is a stage 1. Okay, now stage 1 is called as IFS. The full form of IFS is initial feasible solution, and initial feasible solution can be solved with different methods. Okay, and out of that, we today right now for this question we're going to solve the method called as VAM, and the full form of VAM is Vogel's approximation method. The Vogel's approximation method, that's the full form of the method. Now I'm about to teach you VAM and how it works. It goes like this, that well, in VAM the first thing you will do is draw a nice table. Once a table is ready, now we have to find penalties. Now see how penalties are done. So first I'll find penalty 1, P1. Now the first penalty is in this row, you have to look at the smallest and the next smallest number. So the smallest number of the first row is 8 and the next smallest number is 9. And find the difference of the two, and the difference is penalty. The penalty is a difference of smallest and the next smallest number. Do that on the second row as well. Smallest is 13, next smallest is 11, next smallest is 13. The difference is 2. Smallest is 0, the next smallest is 1. The difference is 1. Okay, so that's how the penalty 1 is going to be. Now you find penalties like you did for the rows. Now you work penalties column like vertical. Now here the penalty is going to be the lowest. The smallest is 3 and the next smallest is 9 and the difference is 6. And then this column, the next column, the smallest is 1, the next smallest is 10, difference is 9. That's the penalty for this column. And the smallest is 0 and the next smallest is 8, the difference is 8. So, to begin with, find out penalty for every row, find out penalty for every column, and these are all blue numbers are my penalty, the first penalty of the question. Okay. Now, once you find penalties for every row and column, you have to choose the highest penalty of all. The highest penalty is 9. Okay. Out of all these numbers. Now, you have the highest penalty at market M2. Now, for M2, you have 3 options. You have a cost 10, cost 11, and cost 1. And the cheapest cost is 1. Right. Now the cheapest cost is 1. So here we will perform the allocation. Now put a circle like that. Now at the highest penalty and at the lowest cost, you mark a circle, okay, and this is where we do the allocation. Okay. Now how do we allocate? Look, plant 3 has a supply of total 2000 units, and market 2 can take, is it 3000? Okay, market 2 can take 3000 units. That's the demand of market, right? Market 2 can maximum accommodate 3000 units. And plan 2, but plan 3 is only through 2000. So write down 2000 over here, because that's the capacity of plan 3 anyways. So for this value here, there is going to be one value which is the supply number and one value that is a demand number. And choose whichever one is smaller. Okay. Now once you choose that 2000, okay. So basically what we decided is the plant 3 will send 2000 units to market 2 is the conclusion. And once you do that, plant this 2000 will become 0 because plant 3 is already sending 2000 units to market 2, and now from this 3000 it will be only 1000 remaining, because now market 2 will need 1000 more because it is already getting 2000 units from plant 3. Now as soon as this step is done, now understand the plant 3 has got supply total 2000, but it's already now sending 2000 units to market 2. So if we say plant 3 is exhausted. Now when you say plant 3 is exhausted, just exhaust this. Now plant 3 cannot supply any more units to anyone because all 2000 units are taken care of. So now that's completely going to be out of the picture, and now we will focus on the remaining cells. Now these are the remaining cells. Now if you see, every time you find a penalty, your table will reduce in size. So now you have only so much. Now this row is absolutely not there. Okay, so it is only so much area that you want to work on, and with that we will find the next level of penalty. Now next we will find penalty 2. The penalty 2 for the first row is going to be again the same logic. The smallest number is 8, the next smallest is 9, so the difference is 1. That's penalty 2 for the first row. And the smallest number is 11, the next smallest is 13, the difference is 2. And now you find penalty 2 for this columns as well. The smallest, there are only two numbers, so one is 9, the other is 13, the difference is 4. And then this is 10 and 11, the difference is 1. And then this is 8 and 15, the difference is 7, right? So now we'll choose the highest penalty, right? All the penalties like 4, 1, 7, 2, 1, the second level of penalty. The highest penalty is 7. Choose penalty 7. Now once you choose that, highest penalty we have in market 3. So for highest penalty, the cost options are 15 and 8, smaller of the two. The cheaper cost, the better. So we will choose this 8 as the cost. Okay. And now you perform allocation here. Now for allocation, you will have a number against it. One is supply number, another is demand. The supply is 2000, demand is 1500. Whichever one is smaller, you write down inside 1500. Now 1500 becomes 0, and 2000 has got 500 more to go. Now 0 is a demand of market 3. So market 3 is exhausted. Just put a cross like that and exhaust this market. Okay. So now your table is smaller than before. Okay. Work with only these 4 cells because everything else is exhausted. This column is gone. This row is gone. So you only work with these 4 cells. And now we find penalty P3. For the first row, you have only these 2 values, 9 minus 10, the difference is 1. Now for P2, the difference is 2. And now penalty 3 for the first row is going to be 13 and 4, the difference is 4. And 10 and 1, the difference is 1. Now on third level of penalty, penalty 3, the highest value, this is a repetitive procedure now, is 4. So the highest penalty is 4 and the lowest cost is 9. So put a circle here and do the allocation. Now for plant 1, you have 500 units of supply and the demand of market 1 is 1500. So you got 500 and 1500. Choose whichever number is smaller. So it is 500. And then this 500 becomes 0 and this will have 1000 more to go. Okay. and with this allocation of 500, now this became 0. Plant 1 became 0. The plant 1 is exhausted. So this is exhausted. Now if you see, there are only these two cells remaining. Right? Now, how do we allocate? Look, you just can't find penalty. Even if you find P4, you just can't do that. Because there is only one number. Already this is exhausted, so you got only one number, and you need a smallest and next one. That's not going to happen, and you cannot get penalty 4. So penalty 4 not possible. I hope you get that. And you don't need also, right? Because you've got like 1,000 required for market 1, market 2, and plan 2 is supplying 2,000. So straight away give 1,000 here. So plan 2 sends 1,000 to market 1, and plan 2 sends 1,000 to market 2, and then they both are 0, and it's all good. And if you can recall the previous problem, this step was already given. You were not supposed to solve. But now here I have solved this whole thing, and the stage 1 is called as initial feasible solution by Wazel's approximation method is the name of the method. Now for VAM there are two more options, like one is NWCR and other is LCM. Maybe we can look at that later. But then VAM is the best method. Look, this is a default method. This is default. So if there is nothing mentioned about which method you're supposed to use, you always go for VAM. It's the best method of the 3. Okay, just remember that point. And well, we've accomplished the stage 1, and we have got your initial feasible solution. Yeah. नहीं 6 लाइव तो चालू है.
लोगों का चालू नहीं हो रहा, वीडियो चल नहीं रहा.